Okay, thanks for coming over for the last talk today. And we would like to start, that we'll be in time. Thanks to Emmanuel and Mathot to come over. Drop the last T, I learned that. And he's talking about expanding OpenNebula's support for cloud bursting. So thanks, and it's your stage.
Thank you. So good afternoon, or maybe should I say good evening. I know this is the end of the day. You are all a bit tired, looking forward to the restaurant tonight. So I won't do something too heavy. Sit back, relax, and you will see a nice picture. So I'm here especially to speak about a testimony. It's really a testimony of what OpenNebula for us in our business supports our business. How OpenNebula supports our business. And how you can make something fun and something real with OpenNebula. So here in our business, what do we do? Well, we say that we provide computational science for researchers to study the Earth system. Okay, it's nice sentence, but it's better with images. We monitor the climate change, the ocean ecosystem, detecting algal bloom, the land use, the atmosphere analysis with the carbon, or geohazard monitoring. What does it mean? It means that here we have scientists that have to process a huge amount of data. But when I say a huge amount, it's very, very big. Satellites data are coming to be one of the biggest source of bit in our cloud providers, especially with the new satellites coming in the European Commission program, the Sentinels, etc. So what we are doing here is we provide the scientists the tools to do and to show those results. Because scientists are scientists. They focus on what they do the best, finding the best algorithm to make those detections. And we do what we do the best. We provide software development, deployment, and operations. So for that, our business is to provide platform as a service in the first definition. How do we do that? First thing to do is that the scientist becomes a developer. We provide the scientist what we call a sandbox. A sandbox is a virtual machine running on a private cloud or private cloud. The machine is not powerful, it's just a test bed where the scientist will bring what he has already done on its own workstation, will try to recompile the source code, adapt it to the computational model, which is Hadoop in our case. That is not easy because there are a lot of conceptual parallelism to adopt, etc. But we bring to the developer, scientist, the tools to do that. Then, second actors in our business are integrators. They come also from the scientific community, but they bring what has been already done by the scientist. As you will see, the scientist will bring application from the process, and here we have persons, maybe bigger company, institutions that comes and picks up what the application the scientists have done and try to make services around that. Services for producers of data, where we have what we call producer deck, which is a kind of marketplace where you find the service ready to be provisioned and ready to process a large amount of data. And the four actors are data providers, for which we provide elastic catalogs and data nodes, most of the time S3 data nodes, and for which we provide on both private and public cloud. I forgot to mention, but the producer, of course, when they have a large amount of data to process, they go on public cloud, which are the most suitable way to provide the necessary power for a processing campaign. For that, we use a tailored contextualization, of course, for every environment, for every user. And as I said before, the scientists bring their process, make applications. The applications within the community hub become services available as appliance on the producer deck. And of course, you need to feed all those process with the data. So this is to show you what we have brought so far. Last year, we were around 30, 40 users. And now we have tripled this number. We are almost at 120 users. When I say 120 users, it means that we have almost constantly 120 users on a virtual machine developing their own application, and that we have to manage. So to manage that, it doesn't mean we have a very large cluster, but we have a cluster, a private cloud, that we have to operate, and of course, users to support. For that, the operations and the support department needs, of course, the tools to do that. And I will show you what are the tools we use around OpenNebula to make that happen. So first of all, we have two platforms. That's for the little history, let's say. We have a development platform. We try to stick with the latest version, but here we are still 4.8. 4.10 will be installed soon. It's a very small and old computer, old cluster. We try to recycle just to make tests. And of course, we have our operational cluster, operational private cloud, on which we provision the actual sandboxes for the scientist. We are still stick to 4.2 right now because we had to move from OCCI interface, old interface, to the new interface, and that has taken more time than expected. What do we do to make these operations efficient? Of course, we cannot pass and we cannot operate without a good configuration management. We have tried many, and our choice stopped in Puppet. It's easy to, of course, have machines consistent in terms of configuration, packages stored, etc. It, of course, ensures the integrity, and we like the code paradigm, which allows us to version the different configuration, but also to branch to make some tests, etc. We already developed and we let's say improved all the time our hooks that allows us to do some dynamic DNS management for the machine, because when a user comes, as I told you, they are scientists, they are not computer scientists. They need that to be easy to access the virtual machine. We don't have a large amount of IP public address, so we have one access point on which they connect with a VPN access server. It installs easily a small client on which every user can access his machine with a defined host name, which has been allocated by the hooks we have done. We also profile the user with a centralized LDAP database, and for which we provide also certification, because we still use X509 certification, even if we are trying to get rid of it, because it's not the easiest way for users to manage. Cloud bursting. So nice, the scientist has done his application. The application is available as a service, and service is available as an appliance. He has no everything to just start machines, but not one machine, 100 machine on a public cloud. So we needed a driver that was, let's say, sufficiently wide to access a large variety of public cloud. Those public cloud that are most of the time we are obliged to work with because the institution has a contract with this public cloud, or because this is the only available public cloud at this time. So that's why we developed G-Clouds for One, which is an adaptator for a hybrid cloud for OpenNebula. The choice of G-Clouds was easy. It's one of the most used cloud interface for cloud providers, and for which we already accessed Amazon, Cloud Sigma, Terradue, Azure, and a lot of other cloud providers with Cloud Stack. We also not only have this developer Cloud Sandbox product, we also develop other platforms. Those platforms are developed in .NET. This is an historical choice I won't explain, but we needed an API to OpenNebula with .NET. First one was developed using OCCI, but actually with some problem with authentication, we decided to a bit in an emergency to go through XMLRPC, a quick XMLRPC API. We have started from a work already done, but we have extended it, and now we are maintaining it as a .NET for One on GitHub. So don't hesitate to check out if you are a .NET developer. We are looking forward your comment, your contribution. GitHub. This is the perfect. We found that GitHub was the perfect way for us to practically implement our concept of laboratories. As I told you, we are working with scientists. Those scientists are regrouped in a concept called laboratories, and in those laboratories, when they have done an application, we suggest them to put it on GitHub for better versioning. Not always public, sometimes private, because there are some, let's say, delicate source code that they don't want to disclose. But this is the way we want to bring also those this science forward. We want to open them also to the sharing concept that we have in open source software development. And this is working actually pretty well, and we are having good surprise that the user are sharing, forking their own application with other scientists, and this is very good also for a better management of application at application level. So, just to bring you some example, last week, an ocean model processing was fired on Amazon. I won't disclose here the institution that did that because it's a defense secret, I would say. But easily with OpenNebula, we provision node, 30 nodes of Hadoop to do a MPI calculation. Also to do, actually we were doing some benchmarking. They wanted to know if their algorithm was going to run better with MPI and few nodes or with many nodes and not working on MPI. The results are still analyzed. And that's it. Other thing we did, especially with the .NET for One API I showed you before, we have done this Earth observation challenge platform where maybe you have seen that with other platform where you challenge yourself and with the other persons of your community around a thematic. For instance, here the scientists challenge it around the ocean color analysis, and they all they each one bring this own process. In a few weeks, they try to make an application, and then according to some metrics and some evaluation model, they are ranked. And this was a good experience that is now operational. And we used OpenNebula here with the first time with our API, .NET API, to provision what we call the environment of the platform, because we have some evaluation environment, larger, which is like an Hadoop cluster with master and slaves. When the when the scientist has finished in his private environment to develop his application, he brings you into the large environment to make let's say the evaluation against a large amount of data and to be ranked. And we use here OpenNebula as well. Here it's one of our latest, let's say, a project ongoing. This is supposed to be the next new way for European Space Agency again. The new way to discover those satellites data, but not only to bring the data, to search for data, but to search also for the processing that are available with the data. And here again, we use OpenNebula to discover what the user has in its own user space on OpenNebula. He doesn't access OpenNebula directly, but he sees the images through the abstraction of processing service. The machine he can provision. Here behind the service, actually, there is a template which can be instantiated at the moment when he submits the job with the data he has selected. And that's also a way to bring to larger user community the cloud also. So to conclude, for us, with OpenNebula, we are able to bring a complete ecosystem for our customers, especially I showed you with the sandbox, which is the developer environment where he will integrate what he has already done, bring the power of starting a large architecture, a large cluster, bringing the power of Hadoop, for instance, using one flow, and new and still to be enhanced the marketplace through projects, through platform where the user is not maybe aware that there is a cloud behind, but what he sees, it's the finality is what the process, the application is bringing as a service, finally. So our future work around OpenNebula is a module to make some automatic invoicing based on the accounting of OpenNebula. We need that now, since we are developing some, let's say, business around the pay-per-use model, where the user will pay the time he uses a machine. So we absolutely need, as a company, to be able to invoice our user with that. We need also a way to we also are going to look forward a more customized dashboard for our user. A lot of work has been done in OpenNebula for the dashboard. It's an amazing job. We are even looking forward to have something like the view, the user view, but even more modular, where it could be possible to come with custom modules in HTML or JavaScript dedicated to a special domain, etc. So that's something we are looking into. And another way of authenticating based on OpenID, since we have now moved to OpenID, especially our host, to delegate the profile and to delegate authorization authentication to the platform. So here are the references I used for this presentation. You can contact us. We are always looking forward new comments, contribution, and of course needs just write to us. Now, if you have any question about what I said, please.
Can you
Yes.
can you repeat the question, please? For the streaming, can you repeat?
So actually, the question is, how do we use Hadoop for a scientist application? Mm-hmm. Okay, so we have developed like some easy command line tools that are actually scripts that makes the job for the user. For instance, I want to fork or to simply copy the repository already done, or we have some archetype generator. So when the user say I want to do a Java sample application, he just create a Java sample application, and the repository with the folders, even the POM file, because we use the POM XML because we use Maven for packaging, is ready. So of course he won't open all the files, but they are ready for him, and he just have to use it. So we have a set of yeah, they are still. It's not magic. There are still some manual steps. We are trying to reduce them as much as possible. We have a complete documentation, but let's say that for them this is not the most difficult. Following a user manual well done and starting an application from that, it's not the most difficult part. The most difficult part is to really integrate the new computational model from sequential to something more parallel. That's more difficult.
Regarding the application of ocean modeling processing, we're referring to post-processing of simulated data or something else. I mean, Hadoop cluster were used for what?
For instance, in this case, well, this part I can disclose is
we are
we are running the model 100 times, and this model with different configuration, what they call the scientists call perturbations.
Okay.
So they perturb the model, and then this has to be done. It's quite quick actually. It's 1 hour each on one CPU, one machine, and this has to be done. If they do it sequentially, it's 100 hours to run on the cluster normally on a workstation.
You mean ocean modeling just as a test? You mean?
And then there is let's say there is the map, and then there is the reduce, where the data, this amount of data is analyzed to find the.
No, I mean, how do you model ocean with the one CPU? That's what I was asking. Or okay. So maybe it was like a test.
That's where my expertise finished.
Okay. No, I thought that it was maybe some post-processing of some data or.
This is where
okay, but
we discuss with the scientists. That is where it's what is nice with this the platform we've put in place is the fact that they reopen the repository, they make a new version, they retest, they ask for new provisioning. Actually, so far what I knew is that the model was running with different perturbations, and then of course to make this we provide part of the tools I was explaining, a WPS server where they can change their parameters for different processing campaign.
I was asking because if you provide a platform in order, for example, to test several configuration, but I mean, usually when you model ocean or you model sea, you need HPC to model it. So we have a supercomputer to run a ocean forecasting, for example. You usually don't run on one.
No. Here actually
so
the goal was to test if it was possible. I don't know what are the conclusions yet, but to see from an MPI program where there was this hyper threading on the machine with different CPU.
So maybe it was some kind of simulator.
Yeah, the first step with this customer
order-
was the simulation. Then once this benchmarking phase will be done, we will pass to another step where they will know how to configure the best their application, and then move to another step that would be to systematic processing or something like that.
Okay, okay.
More questions? Then, thank you very much.
Thank you.